This lecture is on the new mathematics called Isomathematics for a new field of study called Hadronic mechanics, which is a generalization of the conventional quantum mechanics of the 20th century. Now, what is involved, or the way I want to approach the problem, I want to start by giving some historical background of Hadronic mechanics, then stressing why we need a new mathematics for understanding certain experimental facts, which will form the foundation of the new theory of Hadronic mechanics. Then I will briefly outline the rudiments of the new mathematics called isomathematics or genomathematics, depending on the level of generalization. Then, as time permits, we shall give some experimental or new vistas or the application of the theory to scattering theory and some possibly we wouldn't have much time to go into the industrial applications. So historically, I begin with talking about the history of the subject matter of Hadronic mechanics. This was initiated in the PhD program of the Italian-American mathematician and physicist, Professor Ruggero Maria Santilli, who published an article called Embedding of Lie algebras in Lie admissible algebras in the Journal Nuovo Cimento, 1967. The embedding is a process of generalizing the usual Lie algebra, which is based on the Lie algebraic product AB minus BA to a deformed form. Now, the deformed form is easier to understand if we put a metric between A and B and A, so that it will read like as if, to give an example, we are talking about reciprocity between two quantities, let's say left hand and right hand, and I'll say left hand washes right hand as right hand washes left hand. If the washing is not completely reciprocal, you get what we call basically motion or equation of motion. It is this kind of generalization that Santilli introduced by the time some years later, after studying what he called deformed Lie algebra, into what is now called Lie admissible algebra. Namely, instead of AB minus BA, we have ACB minus BCA, which tallies with what I've said. Left hand washes right hand as right hand washes left. That is an example of a Lie admissible or Lie algebraic product, depending on whether the washing by the left and the washing by the right are equivalent. They may not be equivalent. But what is important about this relationship is that it enables us to describe at microscopic level reversible and irreversible processes. We find that all of the quantum mechanics developed in the 20th century based on the Lie product AB minus BA, or Lie algebra as applied to dynamics, that they deal with reversible processes. But in nature, especially when we deal with energy conversion processes related to the new problems of the new clean energy program of an environmentally acceptable and friendly use of or energy conversion processes, we need to generalize and consider the environment in which these operations take place. Now, from a physical point of view and an abstract point of view, the difference we are talking about is different between particles moving in vacuum, for which the theory developed so far very helpful and correct within its domain of description, to non-point light extended particles moving in medium, in which case you have to take account the underlying medium in order to be able to describe physically what is happening. Now, there are two experimental observations that have emerged from this line of thinking. The first is what is called iso-red shift. It has to do with the Doppler effect. The Doppler effect in vacuum is fairly straightforward and is well accounted for by Einstein's theory of relativity for motion of particles or their relative motion in vacuum. Whereas the iso-relativity, iso means it's axiom preserving, but the medium is no longer vacuum. You have a modification of the red shift. There's a shift of the frequency towards the red. This is called iso-red shift. Now, this iso-red shift can be used as the foundation of the new mathematics, the details of which will be given as we proceed for outline. The other experimental observation I'll indicate is that it's called light acoustics. Now, light acoustics can be demonstrated if we show a diffraction pattern produced by light on passing through, say, a dense medium like glass, and we can show mathematically that this pattern arises from dependence of both the speed of light and the speed of matter in the medium on the local variables such as temperature, and as a result of this you have basically a Lie admissible underlying structure of the theory from which one can derive a phenomenon known as light acoustics. Now, these two phenomena, iso-red shift and observation of light acoustics, provide the motivation for generalizing the underlying mathematics. Because what we find is that if we rely on the usual concept of space and time, which in geometrical terms means we rely on Euclidean or pseudo-Euclidean space and time of Einstein's special relativity theory, we will not be able to account for the iso-red shift or the light acoustics. But if we modify the underlying space-time structure, we will be able to account for this phenomena. And that modification, which is coming from the medium in which phenomena are taking place, is characterized by choosing a new unit. You see, all mathematical operations normally depend on the unit we choose. For example, when we say 2 times 2 is equal to 4, we are assuming that the unit of multiplication is 1. But it may happen that if we change the unit, we can get some other number. 2 times that unit times 4, times 2 may no longer be 4, it may be something else. And the unit, what we are calling, we preserve the axiom of numbers we call iso unit. What is more remarkable is that this unit does not have to be positive. It can be negative. In other words, depending on the unit, when you say that -1 times 2 is equal to -2, it depends on the fact that you've chosen the iso unit to be 1. But if the iso unit was -1, you're going to have -1 times the negative iso unit times 2. And in this case, -1 times the iso unit times 2 will equal to +2. It may sound very strange, but mathematically is perfectly acceptable. Now, once we accept the idea of generalizing the concept of unit for mathematical operations, it will apply to trigonometry, it will apply to matrices, it will apply to functional analysis, and this whole process of rewriting or reconstructing the structure of the mathematics is called isomathematics. Now, we'll not go into the details, just talking. One has to now read the paper that defines these structures and see how it works out. But I've already given an example that the iso unit can be a function, it could be a constant, it could be positive, it could be negative, and all these enable us to realize the new structures one is talking about. But most importantly, I give you an example of how the modified of a basic problem of physics which calls for this new mathematics. According to the theory of everything, there's a Big Bang theory of the origins of the universe. It's supposed that at 0 time, or at the beginning of the universe, there was a Big Bang, which involved production of matter and antimatter from light or from vacuum in equal amount. Now we find that if the process was entirely reversible, then there is a possibility that matter and antimatter, on coming together, will again annihilate each other. The fact that this does not happen is explained largely by the fact that the states of positive, systems that have large positive and negative energy, there's matter with positive energy and antimatter with negative energy, can coexist by appropriate selection of the unit. For matter we use positive iso unit, for antimatter we use negative iso unit, so that our energy always comes out positive. Okay, having said this, let me briefly go into what we normally refer to as scattering theory. In conventional quantum mechanics, scattering theory is normally visualized as taking place between point particles, and one of the problems that arises from this is that one does not understand the production of such particles as neutral pion and the neutron. The neutron is one of the particle that is very much involved in nuclear reaction, nuclear fission, and the making of utilization of atomic energy. It's also a source of pollution of the environment. So one has to really understand the structure of the neutron better than presently. The problem at the moment is that because the neutron is short-lived, it doesn't live very long. It only lives about maybe 40 minutes between production and decay. It decays into proton and the electron and something else. Now, if we assume that that something else is a massless particle like neutrino, it doesn't quite add up, because we know that technically the rest masses of the decay products have to be larger than the mass of the bound particle, so that the mass defect that arises when they come together will be used to account for a negative binding energy. But this is not the case, because the mass of the neutron is bigger than the mass of the electron and the proton. And the same thing, if it were ordinary neutrino that has no rest mass, then that model is untenable in the framework of conventional quantum mechanics. But when you go to treat the electron and the proton as extended wave packets, and you take into account the variation of the speed of light within the median of overlap, you find that it's possible to set up a generalization of the underlying Lie structure of the atom or the atomic mechanics into a Lie admissible or Lie isotopic structure, or the compressed system, which will adequately account for the neutron as a bound state of compressed electron and compressed proton. The new structure that has been developed with hadronic mechanics to account for the energy within the bond of compressed hydrogen molecule is at the heart of what we call hadronic reactor, which has been developed by by Santilli and his collaborators in Florida for processing waste. First of all, it could be vegetable sewage waste into energy, or rather a kind of gas which we call magnet gas, and which, when it's burned, does not pollute, or that has doesn't it burns clean, unlike other gases. other gases produced by conventional fossil fuel. The other area in which the new hadronic mechanics is expected to be fruitful is in arising from better understanding of the structure of the neutron, is in the area of processing nuclear waste. Because ultimately, the world is going to depend on energy derived from both solar energy, and which has its origin in nuclear reaction in the sun, as well as in utilization of nuclear energy in our own environment. At the moment, we are stockpiling nuclear wastes, which is a source of pollution of the environment. And one of the dreams of hadronic mechanics is that we need to find a mechanism of processing nuclear wastes into ordinary nuclear material that would be not harmful to the environment. I think that with this kind of brief introduction and outline of what hadronic mechanics is about, the viewer is encouraged to read our publication entitled Foundation Postgraduate Study on Isomathematics for Hadronic Mechanics, in which these lectures are summarized on most of the material. Thank you.